right, so now we're going to do P12, right? This is IXL, by the way, section P12 in pre-calculus, write equations of hyperbolas in standard form. So we'll just click that, and we want to remember what standard form is, right? It's x minus h squared over a squared minus y minus k squared over b squared equals 1. And this is for the x. The a is always there, but the x is there for horizontal ones. Oh, horizontal. And if it's a vertically oriented one, if it's like this, then it's going to be y minus k squared over a squared minus x minus h squared over b squared. But a and b always stay. A is always the first one. Okay, so that's the way that goes. Now we're going to have to find a and b, right? So what's a? A is, this here is what? That's the transverse axis, right? I'm just going to go over everything for you. That's the transverse. That's an S axis. And this distance right here is A. So the transverse axis, the total length of that is 2A. And then we need to draw the box. We're going to go like this and draw a line tangent to the focus. Excuse me, I take it back. Tangent to the vertices, to each vertex, right? There's a vertex there and a vertex there. And we draw that line, and where that line intercepts the asymptote, these are asymptotes, which is a line that's not really there, but it's the line that the function or curve, doesn't have to be a function, this isn't a function, approaches infinitely but never touches. So that's A, and then where the line tangent to the curve intersects the asymptote, that, and you can just draw a little box here. I like drawing a box. It makes me feel like I really know what's going on. So then this distance here is B, and you recall that this is the conjugate axis. That means the partner axis. You remember we had the complex conjugate, the partner, that enabled us to get the imaginary number out of the denominator of the fraction and all that stuff, right? So that's the conjugate axis, and the conjugate axis is 2b, okay? So that's that. And so we have a horizontally oriented hyperbola. So it's going to be x squared, and then the center is going to be h comma k. That's why the h is always with the x. And in this case, it's 0 comma 0, so we don't need that in there. So it's just going to be x over a squared. So what is a? A here, we'll just write it up here. A equals 7, and b equals 8. And those can be, one can be longer than the other. It's not always one longer than the other, like it is in some of the other conics. So that's going to be x squared over 49 minus y squared, there's no h or k, over 8 times 8 is 64, equals 1. And let's enter that to see if I have steered you correctly. Oh, I need to move down where I can read it. There we go. All right, do that. So that, it just takes a while to enter these, right? That's the problem. I'm going to get that out of the way for a moment. x squared. Oops, that's not what I wanted to do. Do that. Oops. X squared over 49 minus y squared over 64 equals 1. And that's how you, I don't know why it keeps jumping, but that's how you do it. You can pause and see that I was right. So let's erase everything. And now this is a vertically oriented one. So this is going to be y. And I'll go a little faster now. So this is going to be our a distance here. A equals 6. And we go like this, and this, and this, and this. And we see right here that b equals 3, right? And we see the center is at 0, comma 0. So because this is an up and down, it's going to be y. We don't need that because it's just going to be y squared over, again, the a is always the first one, 36 minus x squared over 9 equals 1. And that's how fast it gets once you kind of get going on it. So that is y squared over 36 minus x squared over 9 equals 1. I'm going to try hitting the submit button. Let's see if we get to see it. There we go. We got to see the trim. Good. All right. So this is exactly the same as the two that I've done already. So, I mean, the numbers are different, obviously, but it's horizontally oriented, so the x squared is going to be in the front. Oops, I need to change that back to the pointer. There we go, jumping to the next level. Okay, so this is the next level. And all that we see now is that the center is right there, right? Whoa, what in the world's going on there? Huh. I'm drawing a box. I don't want to draw a box. Clear everything. Back. I must have hit rectangle. Okay. That's all right. Who cares? All right, so there's the center. And the center is what? 3, comma 2, right? So h equals 3 and k equals 2. And we're halfway there already, aren't we? All right, so now our a is the distance from the center to a vertex, right? And if this is 3, comma 2, and the vertex is negative 2, comma 2, then 3, the x term, x2 minus the x1 minus negative 2, that equals 5. So a equals 5, which obviously you can count, but I wanted to just do the math because, because we're here to do the math, and you might not have something where you can just eyeball count things, right? Okay, so there's that, and now we got to find b. So we're going to draw this line like that, and like that, and like that, and like that. And now we're looking for our b, which is this right there. So b, and I will just count this one, 1, 2, 3, 4. So b equals 4. So b equals 4, and now we have everything we need, right? It's horizontal, so it's going to be x first. So that's going to be x minus 3. Remember, there's a minus in the formula, So when these are positive, it's going to be minus, right? X minus 3 over a squared. 5 squared is 25 minus y minus 2 squared over b squared, which is 16, equals 1. And that's how we do that, taking care to, put the center points in there. That's the only difference that from what we did before is we put the center points in, right? And now we need to do that. We got to put a parentheses in there. And now we got to get my keyboard. And we're going to go x minus 3. And we'll go outside the parentheses. Hit the squared button. Go down. Put in 25. And I'm going to go over, and then we'll hit the minus button. Put up a new fraction and new parentheses. You can just type the parentheses in there. Y minus 2 outside squared down 16. Don't forget the equals 1 or you will lose your points and have to reclimb the mountain. So that's how you do those if you're going to add in. And I cannot stress enough. I cannot stress enough how important it is until you really get a handle on it to just write it all down, graph it all out. So we'll just kind of say, okay, so that's our h and k, right? So h equals -2 and k equals 0. So that's part of it. And then we got our a, which is this distance right there. That goes from 0 to 6. So a equals 6. And then we go like this, and like that, and like that, and like that. We're finding where this tangent to the vertex intercepts the asymptote, right? And that distance there is 2, right? So b equals 2. And then you can write the equation from there. And since it's up and down, it's going to be y minus a. Not a, what am I doing? The y is, okay, I better just keep going. We don't even need a parentheses because there's no k, right? This is going to be y squared over a. The a is still first. So that's going to be y squared over 36 minus x, and that's x is -2, so that's going to be x plus 2 squared over b squared, which is 4, equals 1. And I guess I might as well just enter that in. Since I've gone this far, so that's going to be y squared over 36 minus x plus 2 squared over 4 equals 1. All right, so this is more of the same, right? More of the same. Again, just find h and k and all that stuff. I'm going to erase this, and we're going to jump a level. What is the equation in standard form? Okay, so now we have to, again, I just can't stress enough, just draw it out, right? Okay. So I probably won't take this problem all the way because I want to try and start keeping these videos shorter, and I'm going to go home. So vertices, 0, 9. So 0, 9, we'll stick that about there, and we'll call that 0, 9. And 0, -9. So that's down there, right? 0, -9. And a conjugate axis with a length of 14. Okay, so first of all, we need to find the center, which we know is going to be directly between the two vertices, right? And you could find that no matter what these two vertices were, you could find the center between them because they make a line. And in this case, it's just going to be 0, right? And you know that it's 0 because it has to be in line with the two vertices. So the center is going to be 0, 0. And the conjugate axis has a length of 14. So here's, we'll just put our A in now. So here's our A length. A equals 9, right? The conjugate axis is the other one, and if the whole conjugate axis is, I guess I'll use blue again. If the whole conjugate axis is 14, that means that this is going to be 7, 0, and -7, 0, which means our B is going to equal 7, right? So now what do we got? We got H equals 0, K equals 0, A equals 9, and B equals 7. And it is since the conjugate axis is the horizontal one, and the vertices are up and down, then that means this thing goes like that, right? Because those are the vertices. And so we know it's going to have y in the front, right? So I'll just finish it up. I don't think I necessarily need to. So it's going to be y and then -0. So we don't actually need that, but I'll put it in there for now. And it's going to be over a. It's always over a in the front one, right? So 9 times 9 is 8 over a squared, 81. And then we're going to get x. H is 0 also, but we're going to be getting rid of those here. Over b, which is 49, equals 1. And we will submit that. Y squared over 81 minus x squared over 49 equals 1. So that's how that goes. And you might get different. You might get so here we have an exact duplicate, so I'm just going to jump a level again. But no matter which set of points you have, all you have to do is just start drawing them out, right? So the vertices, wow, that is just crazy similar. No, this is a horizontal one. It's not crazy similar, and I'm not going to do the whole thing. I know I keep saying that and I do it, but whatever. So -9, 0 and 9, 0. So there is your major. It's not the major axis. I can't remember. Whatever. But the center between those two is 0, 0, right? So the conjugate axis has a length of 16, which means B equals 8, right? So there's our conjugate axis. So that's going to be at 8, 0, 0, 8, and 0, -8, so B is 8. So we have H and K. H equals 0, K equals 0. There's our A right there. A equals 9, and B equals 8, because that's the distance right there, right? And it is, the vertices are, form a horizontal line, so it's like this. So it's going to be x, we don't need that, right? It's going to be x squared over the A, 81, and now I'm doing it again. I can't stop, minus y squared over B, which is 64, equals 1, and we're going to jump a level. All right, so now we got to, okay, so here we're getting up there, Write the equation in standard form for hyperbola with foci. So now we are going to have to remember transverse. That's the word I couldn't remember before. So now we're going to have to remember how the foci fit into this picture. So we'll start with this, and we're just going to drop those foci on the graph. And where are they? They are at -13, 0, -13, 0, and at 13, 0. All right. and a transverse axis length of 24. So first thing is we know the center has to lie directly between the two foci, just like it has to lie right between the two vertices, right? So the center has to be, that has to be 0, 0. So we've already got h equals 0 and k equals 0. And now we got to figure out everything else. The transverse axis is the distance between the two vertices, right? So that's going to be 24. And so A is half of the whole transverse axis, because you remember the transverse axis is 2A, right? So A equals 12, and A is the distance from the center to a vertex, right? So let me get a different color pen here. So we're going to go from the center to the vertex. We're going to go 12 in either direction. So that's going to be one of our vertices. And that's going to be another vertex, and those are going to be at 12, 0 and negative 12, 0. So that gives us, what is that distance right there? That's A. A equals 12. And now we just have to find B. What are we going to do? Well, it turns out that the distance from the center to either focus is C. But it also turns out that, so we're going to have a B somewhere up here. B is going to be this length somehow, right? That's going to be, I'm going to make that a little lighter so it's clear what I'm looking at. That's going to be my B length, right? That's what I need is my B. But it turns out that this length C that goes out to the focus is also the length from the end of the conjugate axis to the vertex. That's C. So we know C goes from 0 to 13, so C has to have a length of 13, right? And we know A is 12. So we know from good old Pythagoras that A squared plus B squared equals C squared. And we know C, and we know A, and we don't know B, so we can say B squared equals C squared minus A squared. All I did was rearrange that equation. And what we're actually looking for the equation is B squared. So we don't even have to bother with the square root on this, do we? B squared equals, what's C is going to be 13 squared minus 12 squared. And for that, I will be getting my calculator. On clear, 13 squared minus 12 squared is 25. So B squared is 25, which means that B is 5. But we don't really care what B is because we don't need B for the equation. We need B squared, right? So now we're just going to write the equation out. So first of all, we know, what do we know? Because of where the focus and the foci and the vertices are, we know that this thing goes like this, right? It's like that kind of, that. So that's how that goes. So we know it's going to be x in front. So the center is 0, 0, so we don't need to put our h and k in. So the solution to this one is going to be x over a squared, right? And what is a squared? It's 12. And no, it's 144. 12 squared is 144, right? Minus y squared over b squared, which we found was 25, equals 1. And that is all we have to do for that one. So let me grab my keyboard and this, and then we go x squared over 144 minus y squared over 25 equals 1. I'll write the equation in standard form. Okay, so now we have vertices and a conjugate axis, but I hope by this time, I'm hoping you're starting to sort of just get a sense of how you draw the whole thing out and everything becomes clear. So we'll start with that and we'll say our vertices are 0, 8, 0, 8, and 0, negative 8. So that's 0, negative 8. And that is 0, 8. So those are vertices, right? Oh, I probably should have left more room. So we know this is an up and down one, so it's going to be a y squared minus x squared style one, right? We know the vertices and we know the conjugate axis. So, okay, first of all, we know the conjugate axis length, but we also need to find the center. And the center is going to be halfway between those two. So again, at this level, the center is going to be 0, 0. And then the conjugate axis length is 4. Well, okay, so let's find A on this first, actually. Where is A? A is the distance from the center to a vertex, right? So A equals 8. So H equals 0, K equals 0, A equals 8, and B is, the conjugate axis length is 2 times B, because it goes all the way across, right? So it has to go 2 in each direction, so it's going to be like that. So these points, not that we actually care about what the points, I mean, we care, but we don't care. You know what I'm saying? 2, 0, and negative 2, 0. So anyway, so that means B equals 2. And that B equals 2 because the center is at 0, 0. Well, actually, it would equal 2 even if it wasn't at 0, 0, right? So that leaves us to write our equation. And what kind is this? It's up and down like that, right? So it's going to be y first. So we're going to have, and the center is 0, 0, so it's going to be y squared over a squared, which is 64, minus x squared over b squared, which is going to be 4. And that's what that looks like. And so you just kind of, we didn't even need to use the Pythagorean theorem, but if you get a focus, that distance, here's the reminder again, the distance from the center to the focus is c, but that distance from the center to the focus is also this distance from the vertex to the end of the conjugate axis. So that's C, and this is also C. And I know I didn't draw it to scale. Not to scale, that's my disclaimer. So here we go. And I think I'm actually just going to leave it here for now. And then, but you do definitely tell me if you have, oh, boy, I would have lost my point. You please tell me if there are issues, like if the next level up is giving you fits or something, giving you trouble. Actually, fits is a little strong, isn't it? But definitely let me know if it's giving you trouble, and I will de-trouble you. All right, so that should be it. Am I right? Okay, y in front, 0, 8, 4, yes. And I suggest that you walk through things first. All right, so let's clear that off. And I'm just going to jump a level and see what's, oh, this is a 28-minute video already. Wow, okay. So more vertices, conjugate axis, that gets you up into 80. Write the equation in standard form, horizontal orientation, so that means it's going to be x. And eccentricity, so let me just tell you about this. What is the eccentricity? The eccentricity is c over a, right? So the centers, they gave you everything you need to know right there. The center's at the origin, so h equals 0 and k equals 0. A equals 5, so a squared is going to be 25. And the eccentricity is 7 over 5. So that's c over a, right? And when we remember how that thing is constructed, even if we don't draw it out, and you got to be careful because it's got a different, it's a squared, what is it? Shoot. It's a squared equals b squared plus c squared for the ellipse. But for the hyperbola, we get to use our a squared, a squared plus b squared equals c squared, right? So we got 25 for the a squared, and we already got the c squared, so we'll find our b squared like that, and the c comes from that, so that's 49. So b squared equals 49 minus 25, which is what, 25, 35, 45. So that's going to be 24, right? So b squared equals 24. So it's going to be, it's horizontally oriented, so it's going to be x squared. I just can't stop. Over a squared minus y squared over b squared, which we found, and who cares what b is? It's the square root of 24. So that's that. Now I'm going to jump a level, see what else we got. Whoops. And then I'm going to get out of here, which I said I was going to do like 10 minutes ago. Okay. So that's the same one, basically, right? You got your A, and you got your A and your C, and your center. You just got to keep track of what's what. Doing that, just like we've been doing. And there we go. Another, that is, you're going to have to do, complete the square on this one. So we'll rearrange that. And I'll just get started here, I guess. We've done complete the square and several other ones. So that's going to be x squared minus 4x minus 3y minus 74, right? Equals 0. And I have learned that it seems better to leave everything over on this side until the end. So we're going to complete the square on this, and it's going to be x squared minus 4x minus negative 4 over 2 squared plus negative, I did that wrong, I think. I want to do plus and then minus. I've done that wrong before. All right, negative 4 over 2. You want to add it in there and then subtract it over here. Minus 4 over 2 squared minus 74 equals 0. And this turns into x squared minus 4x. Negative 4 over 2 is negative 2 squared is 4. So that's going to be plus 4. And that's going to be minus 4. And that's going to be minus 74 equals 0. And this is going to turn into x squared minus 2 squared. Oops, guess what I left out altogether there? Minus 3y. Negative 74 minus 4 is negative 78. So that's going to be equals 78 over there. And this was getting really weird. I wonder if I should go ahead and enter this. So the last thing we have to do is divide everything by 78 to get it into a form that we know and love. 78 over 78 is 1, right? So we're going to have x squared minus 2 squared over 78 minus, and then does 3 go into 78? Yes, actually it does, which is a good thing because that makes me confident. 78 divided by 3 is 26. So that's going to be over, that's going to be y. I dropped the y squared too, didn't I? That should have been 3y squared. 3y squared. And I missed it. It should have been in here and in here and then in here. Sorry about that. So that's going to be y squared over 26 equals 1. And I'll just enter it. And if I worked too quickly and made a silly error, then I will just own up to it. That's not x squared minus 2. It's x minus 2 squared. I can't just, that's, see, I'm making a lot of silly little errors here. Sorry about that. So that's going to be x minus 2, and then that's going to be squared, and that's going to be 78, which is weird, but, minus, oh, we don't need that, because we got rid of that, didn't we? So that's going to be y squared over 26 equals 1. Boom. All right, so that's about it. That's 97. That's the toughest problem you're going to get. And thank you if you made it all this way. And I hope you have a good evening. Bye-bye. Or good morning or whatever you're watching this.